the number which is giving that pay sum output 5. So basically that's that's easier logic, right? So just run a n square loop. That would be, you can now think on the size, speed aspects also. Even if you don't know the complexity analysis or not, that's fine. But even if you just see that for every number you are running a loop, and for every number you're picking every other number which is coming after it. So first you can write a summation sequence. So n minus 1, n minus 2, n minus 3, so on until 1. So what's the sum of n minus 1 natural numbers? So you can see that is the number of times you are basically comparing the pair elements. So that's the one aspect. So before going into the next question, let us see if we can solve it something different. So I mean there is nothing in the restriction on the array sorting, but you can sort the array. That's also fine. If you sort the array, can you think? The question is not necessary to sort it. So let's think if it is really a sorted array. Let's assume that the input is sorted array. How would you then solve it? Can you speed up the process? Is there any idea you think? Can you think of anyone? So I'm saying let's ignore the question first. I'm just giving an incentive to think in the other aspect, in the sense. Let's assume the input itself is a sorted array. So then could you maybe speed up the process on finding these pairs instead of running n square loops? So the previously you're say basically running n square times the exact comparisons, right? Because you are comparing for every element the next element. But I'm just giving an idea. If it's really a sorted input, what can you do now? So just basic arithmetic, right? So there is nothing harder if it is really sorted. So think on this sense. So just see, this is the example, it is already sorted. So what I'm saying is, so once you pick the first number, you can find a pair which is in the this next coming array until it sums up to 5. So instead of going from left to right, what you could do is now go from right to left until you get a sum which is 5, not less than 5. Okay, because what I'm saying is, because let's say 1 2 3 4 5, I'm just focusing on sorting. Why is it? Because some questions really have sorting in the next part. So again, that can give you a better idea to solve the same paradigm. So I'm just focusing on sorting. That's why exactly. Okay. Anyway, this will give you an idea to really think on different approach. Okay. So if you really have sorted input, so what you can do is you picking the first element basically. So you want a 5, you go from the left to right, right to left, and if you want a 5, you want to sum up to 4, right? So once you found the 4, this is a one pair basically. So you output the pair, but you remember this position of 4, and when you start from next position, you start from this position. It's already paired up, so you can start from this position instead of going over entire array. So what you can now think, how much optimization you got really is just you're going every element only once. So this is like of n time, and dependent on n time, while the previous approach is n square. So this really matters in the sense, right? So if you are really having a sorted input, then the optimization you got is really very large. If you, even if you don't think, and even if it's not showing clearly, once you saw the complexity analysis in later classes, you would find that these kind of speed ups are really matters in a real life also. Okay. So another reason for sorting is exactly this kind of reason, right? If you really have sorting on the input itself, you already saw the how much you can speed up. So the exact in real life, sorting is also used. I mean, I think exact. I don't know exact numbers, but if you really compare the statistics of the computer uses from the starting, the machines and chips uses, there is a result that says around 40 to 60% of the computer time, in the sense that even if your computer, even if it's a supercomputer, or even if it's in the cloud, any computer time is spent on sorting and searching itself, compared to all other kind of exact implementations. So the sorting and searching are really common in almost all algorithms. So even if question is not really related to sorting, as having a sorted input kind of gives you that power, right? So this can be again applied into any kind of problems. You will see later on that sorting is very common in that sense. So thinking on, I mean, even if question doesn't ask the sorting, you can think on speeding up in the sense, if you can you sort and maybe speed up that kind of problems. So that's what I want to say for this. So yeah, sorting will be covered in the class even if it's not covered. So you will find some problems on it. So let's go to the second question. Is that, I think it's clear now. I mean, the actual question is clear, right? So assume it's an unsorted array and run an n square loops for that, two loops to get the n square comparisons basically. Okay. So the second question is asking count the number of words in a string. So there is a string. Let's say this is a string input. Hello world call 100. So you want to scan this input. There is an input of size of the string, and after you scan this input, you have to find number of words which are separated by character or tab. So there are two characters you can check on, and the string is terminated by a null character. So you can initialize an array of string, and then you can scan the entire characters by getC, not a scanf. I think you all, I mean, also follow the Piazza. So you can already see the questions which are answered already. So yeah, scanf will not work because in this case there is a space, but there is an optimization. I think it's already taught in the class. You can use something excluding new line, only considering new line for scanf also. I mean, that's also, I think if you go over the previous programs or as taught in the class, you can see that pattern also. So anyway, once you really scan this entire string, then everything now gets easier. You just have to go over the string and find how many spaces or tab characters are in the string basically, and just run a loop on that. Okay. So scan the input into the size of the string array. So there is another character, null character for termination of the string. So scan until that number of characters, and then go over this array to count the number of characters which are not, I mean, which are space or tabs, to count the number of words. So that's the question is asking. So for this single character input is a space character. That's I can take that as a retention, and if you are having only single input, you can just output a 0 as a some checking on the program. Okay. So I think the only problem you will have is just scanning this correctly, properly to the array. Once you have that, you can just run a loop and compare it. So everything else is fine for that. So if you have any problem or if you have any doubts, as I said from the last time, you can just jump in and speak out. Okay, so I don't know whether if you are really understood or not, so just speak out and feel free to ask them anything. Okay. No question is silly or small enough, so don't feel shy, or if you think that question is silly, what people think if I ask it. So don't feel that. Just ask anything. No question is silly. So the learning is mostly based on questioning on your own. That's even if it's not in the class. Okay. Let's go to the third question. Symmetric matrix. The question is asking basically there is an input is an n square matrix. So n is a number of rows and columns in the square matrix, and once you have that, you have to basically scan the input into 2D array. You can say that you can take a 2D array and scan these numbers into that n by n 2D array, and once you have that, you can run a symmetric comparison. Is basically what you're doing here is. So the simple approach I think you can do is just do a transpose of this matrix and see if the input and the transpose is equal or not in every position. So that's a very naive approach, in the sense you are basically creating another array and comparing both the elements positions. So if you find anything which is really differing in the transpose array and the original array, then obviously it's not a symmetric. It's a naive approach, right? But you can also go one step above and say, so the symmetric matrix diagonals are you don't need to worry about diagonals in the symmetric matrix. So that's one thing idea. And another thing is, if you are really symmetric, the upper triangular would be exactly similar to mirror to the lower triangle, right? So you can run a loop only on the upper triangle part, let's say 2, 3, 4, and compare the two with this bottom 2 and 3, this bottom 3 and 4 with bottom 4. So how exactly you can do that is, again, I will leave it to you exactly, because that's exactly problem solving skill you have to develop. So you can write for some examples, let's say pick some smaller example with 2 by 2 square matrix, and think on, in this case you can ignore this, and now think on how would you come to this position and compare with this. So arrays, as I said, is mostly index mapped basically. So how would you map these indexes, and again it's a function, how exactly, what function can map these indexes properly. So that's what you have to develop on your own, because that will help you a lot even in the later exams or questions. Okay, so just think on that. And one idea I can give you is, let's say this is for this input 2, 3, 3, 4, right? So you can ignore this diagonal. So one thing is, for this column, because it's a square matrix, this row index would be this column index, and similarly this column index would be this row index. So if you are really working on I and j here, so you can shift that and access the array of j and I, because now you would basically look into the other part of mirror part, and then you can compare this directly in the input array itself without copying or making a transpose. That's the idea. So, and again you can speed up with only half the matrix comparison instead of full matrix, right? I mean, if you are really making a transpose, also you can run on half the matrix, because it's again square matrix, right? So that's the key idea. How exactly, as I said, you have to map apart from diagonal, and then even if you include diagonal, that's also fine. You would basically get the same diagonal, because I and I are shifting I and j, or j and I is again equal in the diagonal part, right? So yeah, so that's what we can do in this question. So you can do anyway, just compare the elements, and if you have found anything mismatch, that's not a transpose, just output that. So symmetric and not symmetric outputs, that's it. So you can run a loop and break whenever there is a mismatch, that loop, and print that break or set a flag or that thing. Okay, so fourth question. So there is an array of size n. So that's again input size is first declared, and the input. So in the array there is the logic here is there is a repeated twice on this array. Only one is the odd one out. So you have to find that odd one out in this input array basically. So I would, because this is an interesting question, I would expect you to solve it first. Can anyone say any ideas you can think on this problem basically? Let's start with anyone. Anyone can just speak out. Don't worry.
You can do XOR of all the elements.
What exactly you say?
You can just take XOR of all the elements
XOR,
in the
okay,
array.
exclusive OR of all elements. Yeah. So I think that's a exactly beautiful approach, Nishant said. So as you said, bit operations kind of get into any kind of problem, as I said. So this is exactly that kind of example we are talking about. So let's keep XOR once aside. Let's think on naive approach first. So what you can do is just count each element and see whether there is a duplicate or not, right? So you could do, first thing is, very naive approach is you can run a loop for every element, and then compare for every two loops in the sense. So first you will pick a first element, and then you go every element, and if you find any duplicate, so then you can ignore it, and again you can come back to this. You would have to keep track of the duplicates and remove that array and modify that array in that sense. Or you could count the array. We can count the number of elements and maintain a separate array. So let's say you're maintaining array with counts, 1 will be count of 2 and 5 will be. You will run only one loop, in the sense, once you find a 1, you can update that temporary array, let's say. So in this, let's say you pick 1, and once you found this first element, you would update that count into 1. And if you found second one, you would update that count to 2. And one problem would be is how would you map these exactly counts 1 to 2 again. So one approach is you can pick a large size array. So the first index would be 0 element and 1, 2, in that sense. So once you found, let's say here 5, you can update the 5th index is fine. If it is positive numbers, you can update the 5th index to 1 in that sense. But again, the problem with that approach would be if you really have numbers which don't have 1 and 2 and so on, and it has like 400, 500, then it's all wasteful of memory to just create that much memory, right? So that's entirely fine. You can count the numbers, or you can do some other mapping. It's fine if you don't work on directly on arrays. If you find some other mapping, it's also fine. So I mean, you can create a 2D array. Basically, the first array could have the element, and second array can have counts. But the problem again would be how do you really go into that array? So let's say you pick some random array, and whenever you found some element, you're making that element one would be ones, right? So I'm saying if we are picking 2D array and keeping counts in that, 1 would be updated to 2 in this case, and 5 would be updated to 2 in this case, and 6 would be updated to 1. But how would you really look into this array at later stage, like this array, first part? Because you are updating counts, right? So if you found like 2 in this, again after the 6 you have 2, so you obviously have to extend this array here itself like 2, but once you have to update this 2, how would you find this? So you have to loop over the entire array to find the 2, because you are not sorted this array. So this has some restrictions in that sense, right? So counting is again somewhat strict to if you don't know exact range of the input. That's the problem with it. So the exact elegant approach would be again using XOR in this case exactly. So what XOR is saying is basically when you exclusive OR a bit with another bit, if it is a 0, you would get a 0. If it is a if it is the same, you would get a 0, right? 0 with a 0. So if you exclusive OR 1 and 1, then obviously if you exclusive OR 1 and 1, obviously you will have same representation in binary, so you would get 0. And similarly, if you exclusive OR 5 and 5, you would get the same representation, and again you would get a 0 in this case also. I mean, you don't need to think on binary because the system has binary, and if you do exclusive OR directly on those numbers, you would get 0. So once you see this idea, obviously if you run exclusive OR on an entire input array, the only odd one out will remain, because everyone will cancel out each other and only one number will remain. That's the exact number we have to find. So yeah, exclusive OR is kind of again this neat trick you can find. I mean, these kind of tricks will be again you can see in other programs also. So focus on bit operations as I said in the last assignment discussion. So this is one approach. Again, you can do anyway, but exclusive OR is what better suited for these kind of problems to better understand basically. Okay, let's see 5th question. So I think 1 to 4 are easy enough. You can solve with the previous approaches and loops basically. Okay, so 5, let's come to 5 quickly. So there is an input array. This is the input size of the array and input array. So there is a subarray concept. So what subarray is saying is you have to find the number of I can say permutations on this. So you have a permutation of each position, and if you take a permutation of 2 positions, so on and so forth. But those should be contiguous if it is a subarray. So you can't find random permutations like 0th position and 4th position, but it should be contiguous, so you would get less than some permutations. It's not exactly complete permutations in that sense, right? I mean, it's like a subset, but without non-contiguous parts, right? So yeah, you can just think on how can you make them. You can just think on making them. Each single part will be a subarray as per the definition again. So and each contiguous part will be again subarray. So you can make 2 parts, 4 2 2 0 and so on. Is that let me see. Yeah, I think that's fine. So for 1 2 3 4, you would make 1 2 3 4 each as a 1 element subarrays, and contiguous 2 elements now, and contiguous 3 elements until full array. Full array will always also be a subarray. Okay. With that definition, what the question is asking is You have to find a zero sum subarray. So whatever subarrays we can form from that, you have to find if there is at least one subarray which is a zero sum, and if you found that, you have to output it true, and if it's not possible, you can output false. That's what the question is. So let's see if you have other ideas first. Just let me give you a second to think on it. So anyone have any idea?
Sir, we can we can make the cumulative sum of the array up to each index. Then we
Okay.
can see if two adjacent indices have the same sum. This means that if we subtract those, then we get like 0 in the, how do I explain this? I have to draw it somewhere.
Okay, I can draw it for you. It's fine. Okay. So what you are saying is, let's pick this exact array. 4, 2, 0, 1, 6. So what you want to do is you want to sum it up, right?
Yes, sir. Take the
So
cumulative sum.
cumulative sum. Okay, 4, 6, 6, 7, 13, right? Okay, this is cumulative sum.
So if what I'm saying is, so if any two indices have the same cumulative sum,
Okay.
like 6 and 6, it can be any two which have the same cumulative sum. Then this means that all the elements between them have the sum equal to 0.
So exactly, but okay, you got exactly the answer. That's fine. So I think anyone, if you have any doubts, let me be clear for what he is saying. So what he's saying is, if you found same subarray cumulative sum, this is some cumulative sum we are maintaining and separate array. So what cumulative sum is basically summing up the each element in that position. So if it is 4, 4, and 4 plus 2, 6, 6 plus 0, 6, 6 plus 1, 7, 7 plus 6, 13. That's what cumulative sum array we are maintaining now. So once you got the cumulative sum, what he is saying is, you can, if you found something which is duplicate in that cumulative sum array, so in this case 6 and 6, if you found a duplicate, what it is meaning is, so between those elements, between those positions, there is an array which makes a 0, obviously, because if it is only 0, then only we can get a same position, same cumulative sums in that array. So even if it's not 0 in this case, let's say uh, there is another element in this, let's say -1, even then we can do 6 minus 1 is 5, and 5 plus 1 is again 5, 5 plus 0 is 5 again. So yeah, 5 plus 1 is again 6, so sorry.
I mean, you can replace the 0 in the original array with 1.
Yeah, sorry, I cannot draw exactly now. So anyway, you got the idea. Like, my mouse is acting weird. It's fine. So yeah, if even if it's not a 0, even if it's only -1 and 1, when you sum up those, you would get that part. The middle part would be as a 0. Okay, that's what the idea is. So one problem, I think, I don't know if it is really solved in the class. So how would you compare these duplicates in the cumulative sum array? How would you do that now? Anyone? How would you I mean, the idea is fine, exactly, but how would you find the duplicates in this subarray, cumulative sum subarray sum? It need not be contiguous, right? So one idea is, I mean, in this case we got 5 and 5 or 6 and 6 continuously, but sometimes it can be possible that the duplicate can occur at a later stage, because it depends on the entire sum of that part. Let's say so let's say -1, -2, 1, 2, 6, and 5, let's say. So in this cumulative sum, only if you sum up all these elements, you would get a 0. That's the answer we know exactly from this. And similarly, only if you sum up all these positions only, let's say, because we have 5 here and we have 4 here, 2 here, 3 here, 5 here, sorry, 5 here. So only if you sum up from starting to the end of the array, only then you would find this array. So it need not be contiguous. One idea you have to think on. I mean, it can be misleading in the sense, but yeah. So the duplicate can be anywhere in the subarray, and there can be multiple duplicates again. You have to find only one duplicate to really argue on this. So I don't know whether there is a hash or set concept taught in the class. Is that taught? Hashing or setting sets of. If it's not taught, then you can just loop over this array, it's fine. If it is taught, you can then do, I mean, you can do multiple loops to really find a duplicate. That's, I mean, common from the previous questions. That's also fine. But if you have a set concept, then it's very easier in the sense the duplicate finding on sets is a constant time. So you don't need to go over entire thing. You would get the sets later on. So just keep that in mind. Just saying. If, that later stage you can use the set concept or hashing, basically both are same. So that can give you a speed up for this exact approach. Okay. So anyway, you have to find this duplicate in some of that cumulative sum array. It's fine. That's, or you can do a naive approach and do enumerate all these sets and make that find that sets. But it's easier from this approach. Just converting that into n square operations, right? So let's see second smallest element. Okay, so the question is asking, there is an input, basically size of the array and input array. So there is question is asking only second smallest, not the smallest you know how to find, but the second smallest. And ignore duplicates. Ignore duplicates in the output, in the sense there can be duplicates in the input. I think that's what it is saying. It's only mentioned in the output. I don't know exactly. Let me confirm. Maybe. Yeah, I don't know. Maybe someone can ask on Piazza whether there is a restriction in input duplicates or it's only output. So anyway, you can use the same approach for both. So one thing you can do is very basic approach is you can find the first thing is once, as you know, smallest element, how to find it. You can find first as the smallest element for the entire array in a loop, and then you can basically run a second loop easily to find the second smallest comparing with the smallest already found from the first loop. So both the loops are not inside each other. They're basically outside of, I mean, they're, let's say 4 to 0, 1, 6. So you are running one loop to find a 0 in this case. Once you have the 0, you can compare 0 with this now again to find a 1. So if you don't have 0, let's say 9, so you would have 1 as the first output, and then you would compare 1 again, and now you find 2 as the second smallest. So you can run 2 loops to use the same approach. That's entirely fine. But because the question is asking only second smallest, you can maintain a new approach in the sense. So let me see question. Okay. So 4, 2, 0, 1, 6. Okay. So it can maybe, I'm just giving an idea to how to think on basically. So first thing is, it can, every time you think on any problem, just write a problem. As I'm repeating, so just write on paper first, take some examples and think on how would you really solve this approach first. How would you really think with your own, just yes what you're doing, but can you really optimize them in the sense. So even if you got the answer, think on whether it's possible to speed up that. So every kind of algorithm you learn and everything later stages would again be dependent on this exact optimization is what the future courses can be focused on. So let's go with this. Sorry. Okay. So you can maintain two elements. So one would be minimum, and you can maintain another variable minimum 2. So I think you have to name the variables properly. I'm just giving this some random names anyway. So you can keep them both as a track and do that basically. So because it's only second smallest, you can keep a single variable again. If you want third smallest, you can again do the same approach with M3 again. That's again fine, but you have to maybe modify this something on this again. Anyway, so what the idea is, whenever you found something, minimum will start from minus sort of maximum number, something infinite or max into max anyway, as similar to the previous problems. So once you found something which is less than this maximum number, you would update this minimum first. So you would update 4. And since the question is asking ignore duplicates, so what I think is, if it is having a, let's say 2 and 2, so the not 2 and 2, let's say 0 and 0, so the second smallest would be 1 in this case, right? So you have to find this one. So you have to be careful in updating these elements basically. So 4 you would update, and you would similarly update this. You don't update this yet because you only have one element first thing, and then if you found 2, you can update this thing, and you can push this back into this, compare it with this, and similarly update this thing. You have to be careful in comparing what number. I think I made a mess here, let's say, but you have to be careful in basically updating this number based on this current number and also the previous minimum number you have. So if it is something, let's say, really minimum, you can basically update this first minimum, which is really what we have, and you can push this back to this previous second largest minimum, comparing again with the information we have here. So what I'm saying is, let's pick some state basically. So we have 4 here, and we have, let's say we have 3 here in this variable with some input already, let's say, and we observed 4 here, sorry 2 here, let's say. Let me clear them maybe. So I'm saying, let's say there is an array. The variables are 4 and 3. It's not possible, sorry. 3 and 4, sorry. Yeah. So with the variables are 3 and 4, the smallest would be 3 and the next smallest would be 4. We have that already, let's say, and we observed 2 and now. So this is the smallest now with the number actually we have. So update this now with the 2. At the same time, you should not lose this number, because this can now be 3 is the second smallest, right? So basically push that now back into this. So that's what you have to do, and once you complete this entire loop, you can get the second smallest in the last element array. So I think you can do induction approach in the sense, even if you write something and even if you are not sure whether it's working or not, always use induction for these kind of approaches, in the sense, what I'm doing here is I'm assuming the induction hypothesis holds. The first smallest would be in the first element and second smallest would be in the second element, and I'm just making sure that the next element is kind of maintaining that induction hypothesis, right? So at the n+1 stage, my hypothesis says the comparisons should update this accordingly, and I have a minimum in this first position and the next minimum in the second position. So if I can hold this, my program is correct and I don't need to worry. Only I have to take the base case correctly. So that's one thing you can think on, even if before you go to the program solving, as a programming language. So think on that induction always. That can give you, if you're not sure whether it's really working, sometimes you can get the same doubts while you're solving some assignments or in the exam center, right? So how can you really be sure it's working on edge cases or not? So then that case, exactly do this approach. Make use of induction. There are a variety of inductions. I think you can find that online also. But I think induction is, as a whole, can cover you this kind of approach, where if you cannot solve some base cases or some, whether why is the program not working on some cases, then you can think on this induction and think on find the bug in that sense. Even if you cannot solve from program itself. Okay. So that's one approach you can do. So basically you're updating 2 elements, or it's fine if you run, I think there is no restriction on this. So even if you want to run a 2 loops, that's also fine, but that's not exactly what your program is asking. I think that's not what you have to do now at this stage, right? So think on something smarter and something simpler again, not something complex to make it. Okay. So 6th question I think is fine. 7th question is asking remove duplicates from sorted array. So the restriction is already sorted. The input is sorted. So just make sure you find Is there any restriction on size? Let's see. So first line having integer and size as input, and you have array and the input. I have to output the size of the new array and the elements of the new array. So this is what you can do. So since there is no, I mean, you can make a new array, new output array basically for this question. So you can make an array in this case, and you update this array with the first element with the 2. And if you found, since it is sorted array, so that's what you can do. This is what the key idea in this question is. So because it's sorted array, always if you see the pattern, always the duplicates would be contiguous in the input. So just run a loop and compare with the previous what you saved in the temporary array, output array, right? So if it is case, you save the 1, and if you do 2, you save the 2, and if you observe 2 again, compare with this is the output array you have, so compare with this previous position in the output array and say, okay, this is the duplicate, I can ignore it safely, and then go to the next position. And since there is no 3 in this, you can update this, and 4 similarly. You don't need to check the entire output array, you are only checking the previous whenever you find a new number, only just the last number, because it's a sorted array. Okay, that's what you have to do. Don't run naively on entire array. Okay, I mean the entire array to compare the duplicates. Okay, just run in the previous position, because even if it's not mentioned clearly that in the questions, you should think on that way, because some test cases again fail on the larger size in the exams. I think that's what exams are again in the lab exams, I think. So make sure you at least optimize it. It's not necessarily be completely optimization, at least something that's not completely naive again. So just think on your own to make it something smarter solution. That's what. Okay. So check primes. So I think we are getting to the end anyway. So any questions as of now? Anyone? The previous questions? Any doubt or any idea you can think on, and you want to confirm whether it works or whether there is a problem? If you want to ask anything, you can just speak out. So yeah, I think no one has doubts. Anyway, let's move on to the 8th question. So we have to find so there is an input integer, whether it's a sum of 2 prime numbers or not. That's what you want to find, and you have to obviously write a prime check function for that to compare these prime numbers, right? So write that as a separate thing, and true or false is the output if it is a really sum of 2 primes or not. That's what question is. So let's say this is the input for 7. So 7 is the sum of 2 primes, 5 plus 2. So yeah, you can run it 2 loops. 2 loops in this sense. So you can run a 2 loops, or you can run a single loop also. That's also, let me see. Yeah, that's also fine. Okay. So anyway, I think 2 loops is what you can do. But let me give you another idea. So you have a 7 here, and we have to find sum of 2 primes. Obviously, the sum can be only shorter than the 7 by 2, right? So the 2 primes should be in the range of 0 to 7 by 2, because anything sum of greater than these numbers will again be not, I mean, one number should be at least less than 7 by 2, right? So that's one insight you can think on. Then if you now get out that insight, now we'll run a loop from 0. Let me see sum of 2 prime numbers, right? So yeah, not 0. So let's pick starting prime number 2, and then think on what can be summed up with this number. Turn on the question differently. 7 is the sum of a plus b. So you have one number fixed in the loop a here. So what can be b? So since we already know that 7 is the number which should be summed up, so 7 minus b is the number we have to find. So I'm just making the loop, I mean make just rewriting the equation. So we have restriction is a plus b is equal to 7. So once we have the a, I'm just making 7 minus b should be the number that is the next number if it is really, I mean if the equation really works. At the same time, we have another restriction that b is a prime. So once you have this number, sorry 7 minus a, sorry. So 7 minus a would be the b here. So once you have this, the restriction is now check this is a prime or not, right? So just run this 7 minus a and compare whether if it's a prime or not. If it is a prime, then obviously this 7 minus a and 2 is the sum which is called satisfying this equation. If it's not a prime, then you can simply next go to the next prime number in this loop until it is 7 by 2. Okay, that's what you can do. It's a single loop in the sense, right? You're only doing fixing the a and running finding the b based on this equation. Or in the similar way, you can run it 2 loops for a and b both and naively sum up both the numbers to find whether they are equal to 7. So simple rewriting equation, as I said, on the paper will give you this advantage if you see the problem instead of going directly to writing a loops and all. So always think on writing the equation on paper first. Think on making a problem concrete in the sense. Think on creating some equation variables or something. Even if it's not a math equation, just think on some examples and see the patterns. So that's what the problem solving approach is, even if it's not really the computer science problems. Any problem solving approach, you can adapt this exactly. So that's what makes this powerful in the sense. So don't think exactly in the computational, not the computer way, but computational way. That's a mathematical approach in the sense. So with that said, I think we are completed with this. So can last questions, I would just go over them. You can write a array for this, store them as array, and the Roman number conversion is basically asking if it is some string, convert this into the output of Roman numbers. So yeah, you can do this with some rules. So you would find the rules if you observe some Roman numbers patterns, or you can read on it directly, and then once you have them, you can write them as a loop and if condition checks basically. So sum does values back into these numbers to get the sum directly. So there is some restrictions where I think you already know if number is, I mean, if 1 is occurring before v, that's like 5 minus 1, 4, and if it's occurring later than v, I is occurring after v, that's 6, right? So that's restrictions. You have to basically check them properly to make them with sum. So it's not completely difficult. The problem would be only be writing those checks properly. So you can try that and make those rules on your own. So one thing I want to say is don't read the solutions, or if you are, I mean I think it's already the questions or solutions are very easy. So just think on your own again. Even if you heard now, that's fine, exactly as I said. Even if you heard from this lab, you can now think on making it concrete enough. I've not said the complete details, I think, so anyway, so but now you have to think on making that clear and making the program work on your own. Just don't see the solutions, because there is no use in watching the solution and solving it again, because I mean exact solutions are really, so if you try hard enough, if it's not working, then really you can go back and ask our friends or solutions, that's fine, but don't see the exact solutions. As I said, every time think on your own. I mean, that's exactly what the learning should be, right? So focus on your own improvement instead of the comparing with the others in the class. Let's in the mindless average, let's say. So try on your own first thing. As I want to say. You can discuss with the group number, right? So that's one positive skill you have. So there are no groups in the last call 100, I think. So one good thing, you can just discuss among your group members and make something on your own. Right? That's what I think should be your focus. Even if it's not solvable, I think I discussed every idea. So even if it's not clear, just go over them again on your own. And even if it's not clear, just watch the recording, I think, or just ask me later on chat or anything if you have doubts on or errors or bugs, anything. So the last question, I think, is union and intersection. So there are two sorted input arrays. So another thing I want to say is just read the question properly. So I'm just skipping them, even if there are some lines I may have skipped them, but read the question properly and you will get the idea directly to solve them that how you can think on the approach. Okay, so there are two sorted input arrays, and you have to find the union and intersection. So sorted union and intersection is the key here again. So you should not find any random intersection. You should make the output also as a sorted thing. And the input restrictions are this. So you have an input array, first array input, second array size, and second array. So I would go over. I would just give a hint. I don't give the solution, but the hint is one thing is how you move over these arrays. Basically, that's what the question is about. So these are sorted arrays. So one thing you already have the idea. So can you maybe think on approach where you can move over these arrays, in the sense you don't run an entire loop array. So what I'm saying is, can you think on moving once a time? So let me. So let's say where the 1, 2, 3 sorted array and 3, 4 sorted array. Instead of moving over this entirely, like if you want to find this union, let's say you can maybe include one array first and then compare this into the output, the second array into the output you have, and add them. That's a naive approach you have, right? Naive approach in the sense you're not optimizing, or you're not thinking smart anything. And similarly for the intersection, you would find some common elements between these, comparing each and both the arrays. So that's also naive approach. But now you have the sorted as an input trick. So now you can speed up this in the sense, just run over the first array. If you want to find a union, just include them. So until these elements are less than or equal, comparisons are breaking. So one array, either one array would be smaller, that the position of that, the element of that array. So you're just running over two arrays at a time. So there are three conditions for that, right? So when you are running over two arrays, so either the elements of both the arrays you're comparing would be equal, or either one would be less, or either one would be greater. Let's say if you're comparing with the first array. So with this logic, with these cases, now you can think on, if you want to make an union, just skip the equal to element, or if you want to make the intersection, you want to skip. If you want to include these elements, and you want to include only equal to elements, right? So for the intersection, and for union you have to add all but skip the equal elements. And these are the positions, and you have to move accordingly. So if you are finding something smaller in the first array, then you can move over the first array. If you are finding something smaller in the second array, you have to move over the second array, because the output would be sorted array, right? So that's what restriction is. Even if it's not mentioned, that's what the approach should be. So once you move over the smaller elements, so that's easier to make. So then your time would be like m plus n. So let's say the input array is m size first array and n size of second array. So you are moving over entire array once only, and you are moving over entire second array once only, and you're comparing each element with these three cases and updating the output array. So that's like exact speed up, and this is the exact optimal approach. You cannot speed up over this. That's what the limit is, right? So looking over entire element set to make the output array. So always think on writing the pattern first. Take smaller example. If it's if the input example is longer enough, you can make something small example, and think on how you really want to solve it, and use help of the input restrictions in the sense. So those will give you an extra idea how you can approach this instead of naive approach. So yeah, you can make these checks on your own. You can think on your own details. So that's I'm leaving to you. So with that, I think assignment 7 is also clear. So if you have any doubts, we can speak for 5-10 minutes. If you don't have doubts, we can leave, I think. So assignment 6 is Saturday and 7 is Tuesday. I think that's fine. If you have any problems, you can let me or the previous TA know. I think that's fine. You can figure out anything, but make sure you're working if you're fine before the deadline. So don't make things delayed enough, and practice on your own. I don't know what platform you're practicing, but yeah, be a consistent practitioner in the sense that uh, make a group in the sense, so that would be better. I mean, if your practice group can be something different than your assignment group, right? So make something larger, let's say 5 or 6 members for a practice group, and even if there is a club, you can practice something different for your own. I mean, there is a dev club and all, but even then you can practice the pure problems in the sense. You can practice the C problem in this sense, right? So yeah, make a club or make a friend or anything. Just interact on your own. And I think I found the binary search as a good website. So I don't know what others are using, but yeah, binarysearch.com is a good website in the sense you can find something like Discord in the sense. So that's last year website. It was designed only in last year, and it was like a modern take on the previous coding platforms. So you would find the interacting channels in the already, and you can just hop on and ask doubt to anyone there, and you can also find a group and make a room like a Discord room, and you can just chat on that room for with your friends, and you can see the other programs on the same group. So yeah,